Energy. We've been working with you since, well, with TVA since probably 1990. Probably between us, we've been to most, if not all, of your major facilities, coal plants, new plants, things like that. Probably not a lot of the CT sites, but we've done a lot of work with you, not just with the generators. We've put in lots of hydrogen generator dryers. We've put in purity meters and core monitors, things of that nature. We've also done it for a lot of other utilities around the country. We have folks here that are flown in from a lot of places. Beth flew in from Baltimore last night. Janet's here from Richmond. They're both from Pentair. Bill Bailey came down from Connecticut.
Oh, wow.
And Peter probably came the furthest from Montreal. Peter's going to kick things off for us. And just a quick little preface. We actually, Ken and I, our business, we sought Peter's company out. We have, are you two familiar with core monitors?
Yes.
We are as well, but we've sold them. We've installed them. We've tried to protect them, tried to find ways to keep oil out of them, mostly unsuccessful. And one of the things that we've discovered through the years is that utilities ignored them. Even if they didn't ignore them, you know, they got covered with oil, and it still amazes me in our travels that they're online and no one pays them any attention. So in essence, they don't work. For a long time, we've been trying to find a way to accomplish something, the same thing, and find something that works. It's a long way of saying that that's how we got in touch with QPS. We sought them out, and their technology comes with the old W option. It works. And it's not susceptible to oil and things of that nature. So with that, I will turn it over to Mr. Peter Seven Beer Kung.
Good morning.
Good morning.
It's my pleasure to be here. I'm going to talk about the failure mechanism of most generators, especially the large one. And then talk a little bit about the technology platform we use to solve this problem. And walk you through that, but we only have maybe 45 minutes or so. I leave some time for a question and answer period. This is a very informal presentation. Feel free to stop me anytime you want some elaboration on a particular point. You have a question, a problem you want is dear to your heart, let me know, and I will tailor it. And I have prepared some CDs. It's literally everything you want to know about our company, together with our patent portfolio and white paper, 2 webinars that we made in the last 6 months. And actually today the presentation will be a synopsis of those. And so if you want more details, you're welcome to go into there. It was working before. Oh, okay. I'll press this. Okay. So the objective of the presentation today is to let you know about our company and myself. I am of the semiconductor background. Back in 25 to 30 years ago, started at Motorola in Phoenix. And it's because of that semiconductor background I was able to pick up the area of photonics technology. And in fact, I contributed to the evolution of that technology that give rise to today telecom, where you can now make phone calls very cheap, 2-3 cents a minute. So that we play a crucial role in that. And the technology we want to discuss today is called fiber grating. And this is analogous to the transistor, invented way back when, 50 years ago. We see this as an enabling technology to be adapted in all kinds of industry. Now, we pick power industry because some of the inherent benefit is uniquely suited I will go through these to explain to you. And then give you an idea of our product line. We have several different product line targeted at different type of users. And then we'll introduce you to our new solution. This is a world first. There exists solution that can monitor vibration amplitude growth inside the generator that exists. However, for the first time, with the same sensor, we can now help you monitor vibration amplitude as well as hotspots. Hotspots that are caused by PD, partial discharge, which is one of the most significant reasons for the failure of generators. So, you have seen me. This is a famous 7 beer. And the picture was taken in Paujan, India. Now, my history is quite simple. I think it's almost set up to do this. Semiconductor background allow me to make use of very complicated tools, and we invented a tooling for volume production of this technology, okay, called the phase mask. Then with that, I learned from the customer how they use it, and I got hooked. And I developed that, and then eventually we developed a whole bunch of products enabling telecom to have 1,000 times increase in throughput. That's what we did. And the customer we sold to are big names like Alcatel, AT&T, all those guys. By now, unfortunately, they suffer because of the telecom implosion. But at that time, we were shipping something like 8,000 to 10,000 pieces per month. It was an exciting time. And then, of course, the implosion occurred, and we have to reduce the size from a 270 people company down to 18. It was painful. And eventually, I said, well, why not take the technology and adapt to other industry? And so we are starting from scratch, and naturally all the products we developed before are of no use, because these products are basic solutions to address different problems. So we invented a thing called vibrofiber. The original technology is mainly interesting for measuring of temperature and strain in difficult situations like really hostile environment, like in the dam, in the ship halls, the buildings, but rarely do you see a vibration made with this technology. We are the only one. So today is this. And what enables volume production is a simple pieces of glass like that. Okay, you see color fringes over here. It's just because of the semiconductor processing that we did, and the technique is the same, like semiconductor people use, but the dimensions are very small. This is the period of what's in here is 1 micron. You can't see it. Now, how it works? Well, the phase mask becomes a beam splitter. The light we use is not ordinary light, it's UV. This UV light shining onto the optical fiber has the advantage of printing. You see this little gridded region. This is the interference region when the beam got split into 2 different phases. Where they overlap is like the interesting region. So we need to put the fiber right behind the phase mask, 200 micron away. Okay? So everything we talk about precision. This is very unique. It's not something that you can do in a mom and pop shop. So now, here comes the major benefits. Well, you see optical fiber is kind of as small as your hair. Very small, made with glass. Now, that particular nature allows you to place it anywhere you want.